Hey guys, welcome to our next installment of Explain Everything, which is the app I'm using while I'm out. Excuse me. I hope it's going okay. If it's not, you guys can email me. Don't forget my email address is... Alright, a little bigger. M. Jones at cuhsd.net. Okay, don't forget that. If you want to email me something, you have a question about the homework, I can check it many times a day. Alright. So here's our quick notes. To add polynomials, you're just going to combine like terms. Don't forget like terms. We have x squared plus 3x squared. These ones are like terms because they share, well, they first share the same variable and the same power. They're both squared. And so still, some of us are forgetting here, there is a missing what? Hidden 1 right there. And so if I have 1x squared and then 3x squareds, how many do I have in total? If you're answering in your head, 4x squared, you'd be correct. So don't forget that about combining like terms. Okay, yeah, so don't fall into the mistake that the variable and the exponent are going to change. See how they did not change x squared and x squared, still gave me an x squared because that's the thing that I'm adding. The thing that I'm adding is an x squared. I don't know what it is yet, so I can't change it. But I do know that if I have one of them plus 3 of them, it's going to give me 4 of them. So x squared is my thing that I'm adding. 1 here, 3 there, give me 4. That's what they mean here when they say adding exponents. Exponents, when adding, exponents stay the same. And then finally, be careful with the negative sign. The negative sign, you should first distribute the negative sign to all terms in the second set of parentheses. Everything will become the opposite. And let me show you guys that real quickly on the next slide. Perfect. Okay, so here are our 4 examples. Let me go ahead and do number 2 first, since I have this negative sign here. And it will illustrate what the last rule was, that we should change the sign to everything. So here we go. I'm going to change and distribute this negative over here to the 5x, which is positive, and it will now be what? Negative. The negative 12x will become positive 12x. And then finally the positive 6 should become minus 6. So to rewrite it, I have 4x squared plus 2 minus 6x minus 5x squared plus 12x minus 6. Kind of tight there, but it worked. Okay, so you need to check out what we have. What are our like terms? I have an x squared here. How many x squares do I have? You should be saying 4. How many am I taking away? I'm taking away 5. Excuse me. So 4 minus 5 is negative 1. So here I'm going to result in combining those two to have negative x squared. Then I'm going to look for my next term in line, and you might want to do the 2. It doesn't matter, but proper order would be that you would do the other x's first. And so I have x to the first power. So I have negative 6x, and then over here I have plus 12x. And so I can think of this as 12x minus 6x, or I could think about it as negative 6x plus 12. And it's the same exact thing either way. So let's go ahead and combine those two. These should give me a plus 6x. And then finally, I will take care of my constant terms. My constant terms here will be, I'm going to switch to red, the plus 2 and the minus 6. The plus 2 and the minus 6. I'll stick with the red just because it will pop out a little bit better. So plus 2 minus 6, what do you have there? That's like saying I have $2 and then I need to borrow 6 from my friend. I don't know if it's a good example, but it's negative 4. Negative 4 or minus 4. So our final correct answer here is negative x squared plus 6x minus 4. And because all my like terms have been combined, I can do nothing else. I can do nothing else at all. Okay, I'm going to skip back to the first example. And then I'm going to let you guys tackle the bottom two. And then I'll show you a result after you've had a few minutes. So up here, do I need to distribute the negative sign? No, there's no negative sign, right? So I don't need to do any fancy distribution. So here it's just going to be a matter of combining my x squares with my x squares. How many x squares do I have right here? Can you see any? Before you say 0, don't say 0 because I can see it. Right? I can see I have 1 right there. That's why mathematicians are annoying, I know. They want you guys to see the invisible stuff there. But they would say, well, there would be 0 x squares if there was no x squares at all. If you couldn't see 1, then there's 0. But since we can see 1, then we know that there's 1. Okay, so x squared plus 3x squared, that's a total of 4x squared. And then my negative 5x and positive 8x. Remember, there's always that battle happening between positive and negative. And here it looks like the positive wins by 3. So I have plus 3x. And then finally, I have my constant terms, minus 7, minus 9. So I'm digging a deep hole there. So minus 7, minus 9, I'm going to add them because they have the same sign, giving me negative 16. And it's as simple as that. You have just combined two polynomials. So now would be a great time to go ahead and pause the video. I'll give you a second. I'll write out the word pause. And you should have the thing paused by now. In a second, when you guys have taken about, I don't know, maybe a minute or two, we'll come back and see if you have the same thing that I do for number 3, and then we'll do the same thing for number 4. Okay, I'm going to be honest. I had to go back and erase my answer because when I started explaining it a minute ago, I fell into one of the traps that I think some of you guys might have fallen into. Did any of you guys get plus 15 right there? Anybody get plus 15? I know, just to be very honest, I could have easily hidden it. I got plus 15 right here just a minute ago, and it's because I did not distribute my negative sign to the 13 when I first did this problem. So even your teacher is prone to mistakes. You guys already knew that, didn't you, though? But so don't get discouraged if you find yourself making mistakes, because I have been doing this forever. Remember, I'm 54 years old. So I've been doing this for a long time, and even I still make mistakes. So don't be too sad if you make some for yourself. Anyways, this is the correct answer, though. I have gone through and double-checked it. It's x squared. Now, there's no other x squared term. There's nothing over here that has an x squared in it, so I just keep what I have. How many do I have? I have that magical invisible 1 in front of there. Then, this term had no x to the first power terms. So since there's nothing to add it to here, we keep the same thing after we have distributed the negative sign. So that's why we have negative 11x. And then finally, the trick that I fell into the first time, we had to take our negative sign and distribute to the negative 13. That would make it minus 13 plus 2 minus 13, and that's where I got my negative 11 from. So I'll give you guys just a minute to go ahead and pause the video once again. And I'll pick back up after I have combined all of my like terms in this jumbo problem. If you guys are doing well now, you're going to do great on the homework. Okay, last thing here, I'm going to go ahead and supersize right here. Supersize my problem. Okay, great. So, oh wait, I told you guys I would just give you the answer. Pause. Okay, the surprise is over. here is the final answer. Let's go ahead and talk through it for a second and make sure you guys understand where everything came from. So, first off, looking back, do I have... it's best to look at the problem all the way through. You could start just adding stuff when you see it, like X is here and X is there, but I would rather go forward and look at it and be a little systematic. I would rather go forward and look and see, what do I have to mess with here, and what's the biggest term I have, what has the highest power. And so if I look quickly through, I can see that the highest power I have is to the third power, x to the third power. So I went ahead and took this negative sign and distributed it to the x to the third power, giving me negative x to the third power. After that, I went and saw there's no more x to the thirds, so let me focus on x squares. Do I have any other x squares besides this 3x squared? I have 3 right here. Do I have any more over here? A quick look tells us no. So that term stays unchanged as well. Now for the hardest part of it maybe is our x to the first power, x to the first power. So here I have a negative 9. Will that change? Do I have a distribution to do in here in the front? No, I don't. Here, so then I know negative 9x is going to stay put. I'm going to be adding x, no changing the signs here, but negative 9 plus 1 gave me negative 8. So I'm going to put a little placeholder up there. Negative 8x. And that's from this guy and that guy. And looking over a little further, I have my plus 7x. And so you might think negative 1x, right? Because negative 8 plus 7x is set, right? That's not what I have here, is it? Why not? Again, that sneaky negative sign needs to be distributed. Take that negative sign and make this negative 7x. And so this negative 7x combined with the negative 8x gave me a proper negative 15x. So I'm done with my x's, and then the last thing to do is to check for my constant terms. So plus 1 plus 2 is 3. Minus negative 4 gives me really a plus 4. And so that's where I get plus 1, plus 2 is 3, plus 4 is 7. And so now you have seen this problem in its entirety and know the steps, just in case you missed them yourself the first time. Okay, I'm going to make sure that you guys have plenty of problems to do now, so I'm going to bring up a page that you're going to have to copy the problems down. I'm sorry, but it's just hard to get there during school hours, so I can't get there during school hours because I'm off right now. And they close the copy machines after 4 o'clock. So you can thank the copy machine hours for the copying job you have to do. See you guys next video.